Okay, so kita dah cakap pasal Young's, we talked about shear, and we talked about bulk. Oh, I forgot the equation. Okay. Sambung recap ke tak ya? Tak yalah. So Young's is, remember modulus is, okay, I forgot to recap about this part. So modulus is actually stress over strain, right? Okay, now depending on whether it's tensile, shear or bulk, so kita tahu stress kita ada F over A, it's either F perpendicular, F parallel, or just total F. So it depends on whether you want to use Young's modulus, shear modulus, or bulk modulus. So let's go for example such as Young's. Young's modulus, which is Y, is stress over strain. So the stress for Young modulus is F perpendicular over A. F, what is the symbol for F? It is Newton. Sorry, what is the unit for F? It is Newton. And A, the SI unit, is meter squared. So that's your stress. Okay. Now, what about the strain? Sambung kat sini. Okay, strain, 1 over strain. So that is, strain is the change in length over the initial length. So change in length over initial length. Now 1 over that gives me, so saya kena naikkan ni ke atas. Okay. So this becomes L naught. So the original length over the change in length times F perpendicular over A. And A is meter squared, F is Newton. L, length is in meter based on the SI unit. Change in length is also meter, so it cancels out. What if they give you a change in length that is in centimeter and the initial length that is in centimeter? Boleh. You don't have to convert it to SI unit because why? It cancels out. So centimeter dengan centimeter also cancels out. If they give you a unit in millimeter, millimeter cancels out. Now, the tricky part here is when they give you a change in length in millimeter, but the initial length is in meter. Now you can't cancel those out. What you have to do is convert everything to SI unit so that you won't make a mistake when you are calculating. Okay, so that is something to remember. So let's just put meter here. Okay, so buang ni, buang ni. So Y is equal to something that is in Newton meters. Any questions? Okay ke? Alright, okay. So here we can look at this table. Young's modulus has a unit of Newton over meter squared. Shear modulus also has Newton over meter squared. Bulk pun sama. And why is that? Can anyone tell me? Kenapa unit dorang sama? Kita tahu bulk is about volume elasticity, but why is the modulus Newton per meter squared? Any guesses? Salah tak apa? No guesses? Semua orang blur?
Sebab pressure.
Sebab pressure. Pressure. No, it's not. That's not the right answer. Any other guesses? Thank you for trying.
Force dengan area.
Force dengan area, okay. Tapi apa kaitan dengan volume? Where did the volume disappear? Why is the bulk modulus still Newton over meter squared when it is about volume?
Sebab nanti atas dengan bawah tu dia akan potong untuk strain.
Untuk strain, betul? Correct. Siapa tu? Siapa yang jawab tadi?
Umar.
Umar. Okay, thank you Umar.
Yeah.
Betul.
Welcome.
Okay, so let's say bulk is still stress over strain, right? Okay, so what is the formula for stress for bulk? It is the total F over A. Total F over total A. And then strain is change in volume, right? The change in volume over, saya buat macam ni lah. Change in volume over the initial volume. And like Umar said, benda ni akan potong. Dia punya nombor tu ada lagi lah. The number is still there. But the unit, meter cube over meter cube, cancels out. So what am I left with? The number is still here. The unit cancels out. What am I left with? I'm left with Newton over meters squared. That is why your bulk modulus is in Newton meter squared, because the volume cancels out. The unit, yeah? The magnitude is still there. Okay, I hope that makes sense for everyone. It is the same case for shear modulus. Again, strain, the punya units cancel out. We are left with Newton meter squared as well. Okay, let's do an example. Hopefully it is more clear. Oh, terkasih solution pula. Kejap. Patah balik. Okay, so I want everyone to try this one. Okay, I'm gonna give you 7 minutes. 7 minutes to figure it out. You can discuss with your friends if you have if you can, but I don't think so. Senang je, ni Young's modulus. Just use the equation, apply it, and I will call out someone to help me out. Okay, I want someone to tell me the equation. I want someone to plug in the numbers. I want someone to give me the final answer. So please try it. I will call someone randomly after 7 minutes. Okay, 11:36. You can ask me if you have any questions. Excuse me. Sebenarnya 7 minit tu lama sangat. Tak apalah. Baru lagi. Dia kasih jawapan dia. What happened? Oh, something crazy going on. Sorry, sekejap eh. Whoops. Whoops. Okay, one more minute before I call someone, my lucky winner. Can I get Ishraf or Ichab to give me the stress? And then, who was it who liked mangoes? Was it? Okay, I think it's Nadira. Okay, I found it. Nadira Yusri, Nadira. Okay, Nadira, the mango person. Ishraf, the person who did not care that I called his name wrong. And also, Nadira buat string. And then Nick. Nick, please find me the magnitude of the stretching force. Okay. Ishraf, are you there? Duplicate slide. Buang je. Okay, Ishraf, is Ishraf there? Tak dengar pun bunyi. Ishraf tak datang ke? Sini sekejap. Ishraf ada ni? I can't hear him. Ishraf. Hilang. Okay, let's start with Nadira. Nadira, are you there?
Yes, doctor.
Okay, can you give me the string for
The
this?
string, the formula. The string. Should I give the answer straight or the formula, doctor?
The formula.
Right. String is equal to a change in length, and then over the initial length.
Okay, so what is the value over here?
1.5 times 10 to the power of -3 meter.
Okay, and this guy over here?
2.05 meter.
All right, thank you.
Right.
Ishraf hilang lagi ke? Ada tak? Ada. Okay, saya tahu dah. That's why I like to call people individually. Okay, is Danish there? Danish?
Yes, Doctor.
Okay, ada. Okay, what is the stress? What is the equation for stress?
force per area.
Force per area, okay. What is the area in this case? Since we are finding force, what is the area? How do you find the area in this case?
Using pi.
Using pi. Maksudnya? Okay, sekejap. Saya lukis. So kita punya, we have a steel wire. A steel wire looks like this, up close. So bila saya stretch macam ni kan? Okay, this is me stretching the wire. So this is the F that I'm applying. What is my A? What is the area of this guy? What is the
Pi r
area of the circle? Area of a circle? Anyone?
pi r square.
Pi r squared. Pi
Yes.
r.
Pi r squared. So what is the R here?
1.2.
1.2. 1.2 millimeter. Tak payah convert to SI unit.
It should be 1.2 times 10 to the power of negative 3 meter, right? Doc?
Ya, betul. Okay, Danish, we need to buckle up sikit lah. Okay. 1.2 times 10 to the minus 3 meter. So that is your meter squared. Sorry, that is your radius. Okay, this is your radius. So this is pi r squared. So that is your area. Okay. So it's not pi, it's pi r squared. What is the r here? This is the diameter. So diameter kena bahagi 2 to get the radius. Okay. So this is how this is how you guys got 1.2 times 10 to the minus 3. Okay, so now to baru stress and strain. Now let's put it into an equation to find out the force. So here, can we go, is Nick here?
Yes.
Okay. Can you give me the equation to find Young's modulus?
Tensile stress over tensile strain. So it's force in initial length. Yeah, force times initial length.
You're giving me the equation. A times change, right? I'm losing you. Oh, Nick dah muted.
I'm sorry, I couldn't hear the last part.
Okay, so this is the equation. Can we plug in the numbers now?
Oh, okay.
Okay, hilang balik Nick. I think Nick has poor connection, but okay, let's do this together. 200 times 10 to the 9, right? Newton over meter squared. Okay, so F, we are finding out what F is. Our initial length is 2.05. And A is, this is the guy over here, times 10 to the minus 3 meters squared, pi r squared is A, and the change in length is stretched by 1.5 times 1.5 millimeter. So that is, let's make it smaller. Is it possible? Okay. So this guy is your, that is your area, and the change in length is 1.5 times 10 to the minus 3. Oh, that's bad. Okay, so everything was changed to meters. Mana-mana yang ada millimeter tu, we changed it to meter because kita nak semua sama. Kalau semua millimeter, it's fine. But now we have millimeter and we have meter, so we convert everything to meter. That is why we changed it. What happened here? Oh, dia kecil. Okay, so F should be, I don't know, use your calculator. You will find out that it is this guy. 662.03 Newton. Okay, so this is laju punya case lah. But why did we go through all the process panjang-panjang macam ni? Because I wanted you to understand what is strain, what is stress, and then baru masukkan dalam Young's modulus. Okay, I hope that was clear. Any questions so far? Did everyone get this answer? And Danish needs to know what is the area of the circle. Danish? Okay, so okay everyone, I'm gonna proceed if there are no questions. Oopsie. Okay, let's do this one. Yep. We duplicate this slide. One. Okay, so determine the minimum radius of a metal wire. Okay, so now it's asking what is the radius of a metal wire if it is used to support 5 kilonewton. So that is your force without exceeding its elastic limit or your modulus of 3.7 times 10 to the 8 kilogram per meter second squared. Okay, so this is 3.75 times 10 to the 8 kilogram meter second squared. So why is the elastic limit, why is the unit for elastic limit kilogram over meter second squared? Can anyone tell me? Why is it not Newton per meter squared? We learned about elastic limit or modulus, it was Newton per meter squared. Why is it kilogram over meter second squared here? Okay, can I get someone to answer that for me? Who is my lucky winner? Can I get Louis to tell me why? Is Louis there? Are you there, Louis? Louis is muted. Yeah. Okay, Louis is unmuted. I do want to check. Doctor, can you hear him? No, I can't. Tak boleh dengar lah, Louis. Can you like write down why it is in kilogram over meter second squared if you can? Okay, if Louis cannot answer it, I'm gonna ask someone else, so you guys better figure it out. Because force is in kilonewton, doctor. No, that's not the answer, but good try. Can we get, thanks Louis. Can we get Aisha then? Aisha, why is the elastic limit in kilogram over meter second squared? Aisha Fatima.
Yes, doctor.
Yeah, the picky eater.
Not sure
Not sure. Guess? Salah tak apa.
because
I'm asking kenapa Newton meter squared was what we learned earlier, but here they are telling us elastic limit is kilogram over meter second squared. Dun dun dun. Okay, nobody knows?
because kilo
Siapa?
kgms -1 is the same with Newton.
The same. Newton.
No, I'm not sure.
Tadi siapa yang jawab?
Aisyah.
Oh, Aisyah, okay. Okay, thank you for trying. Almost there. Almost there. Okay, I want the person with 10 cats, Christina. Are you there?
Yes, doctor, I'm here.
Apa dia?
Can you hear me?
Yes.
I'm not sure either, but
Not sure. Guess if you have to, if your life depended on it, for you to guess. What is your guess, your best guess? Tak salah tak apa, we are learning together. This is why I ask questions in class. Tak ada jawapan. Can't guess. Yeah.
Newton is equals to 1 kilogram ms negative 2, right?
1 kilogram ms negative 2. Yes, betul. But this is over meter second squared. Like,
Doktor,
huh?
dia ada relate dengan pressure ke? Macam stress gitu.
Tak ada. Ni semua pasal units je. Okay, anyone wants to get for the whole class?
Dia ada libatkan graviti ke doktor?
Gravity ada sebab ada Newton kat sini. Betul. Dah tak ingat Okay. So nobody could answer me? Betul ni. Ya Allah. We have a lot of work to do. Come on guys. Okay, last question lah. Okay. Lepas ni saya jawab. Can we get Jaya? Jaya deepen. Jaya. Is Jaya there? Tak dengar Jaya, kuat sikit.
Doctor, is it because like force is also can be considered as mass times per acceleration? So when you put it in the formula, it comes kg.
Apa? Mass times acceleration. Lepas tu?
And then according to the formula, it is force times by the initial length. So when
So, and then divided. If this guy is meter squared, this is also meter squared. Okay, let's work with what Jaya just said. Thank you, Jaya. Okay, so what is mass here? Mass is kilogram. That's the SI unit for mass. What is the unit for acceleration?
ms negative 2.
ms negative 2 over meter squared. What happens? Meter squared. Meter divided by meter squared, what happens? This guy becomes meter. This guy becomes meter second squared. Sama tak? Okay. What is Newton? Remember, F is equals to MA. F is Newton. So M is kilogram meter second squared. Betul dah Jaya cakap tu. But now we have meter squared over here. So this guy is A. So this is meter squared. So that is how the elastic modulus is, it can be kilogram per meter second squared or Newton over meter squared. Sama je. It's just a change in units. Kalau masuk exam ni, habis confused semua orang. Okay, so this is important to know. It can be in Newton over meter squared or it can be kilogram over meter second squared. Okay, I hope that's clear for everyone. This is not even the solution. Baru cakap pasal unit. Okay. So let's try to do this one now. Okay, can I get Danish again? Kita bagi 5 minit untuk semua orang try this. Again, I want Danish to help me out with the stress and ada orang lain akan jawab strain, ada orang lain akan jawab the final answer. Okay, let's try to do it in 5 minutes. Okay, any questions you can ask me? 5 minutes, 11:57. Danish, fokus lepas ni awak kena buat stress. Jangan main game dalam kereta dalam kelas saya. Kita ada setengah jam lagi nak belajar. Sikit lagi. Lepas tu korang rehatlah. Is Ishraf there? Tadi Ishraf tak ada. Mana Ishraf?
Yes, I did.
Depan ni awak jawab strain. Pergi mana tadi? Rotan nanti.
Pergi toilet.
Okay, gitu ada tak apa. Nasib baik. Okay, Ishraf, Ashrin Danish, Stress, Ishraf, String. Okay, yang seterusnya tu lucky winner. Bising sikit kawasan rumah saya ni. Sorry. 1 minute to go. Okay, it's time. Is Danish there? Danish.
Yes, betul.
Okay, kali ni boleh jawab tak? What is stress?
InsyaAllah betul.
Okay, insyaAllah. Okay, what is stress?
Force per area.
Force per area. Okay, so what is the force in this case?
5 kilonewton.
What is kilo?
5,000 Newton.
5,000. Okay. Newton. Okay, what is your area here? What is the equation here?
2 pi r square. Pi r square.
R squared. Baik, betul. Okay, pi r squared. So R kita tak tahu kan? So that is what we are trying to find. Okay, thank you Danish. Dah tahu dah area of circle. Thank you. Saya bukan nak pick on you Saya betul-betul awak faham. Okay, Ishraq. What is the strain in this question?
Perubahan
Perubahan. So what is the strain here? Ini awak tak boleh tak kisah tau. Kena kisah. So what is the strain here?
saya tak tahu.
Tak tahu. Betul-betul tak tahulah. Dia tak tahu ke ataupun tak ada kat sini?
Tak tahu.
Tak tahu. Okay. Susahnya nak suruh orang cakap. Okay. So strain kat sini, in this question, they didn't give you strain, right? So there's no strain. So why? Okay, let's do with why. So now I'm sure it's a little bit confusing. This is an elastic problem, but there's no strain. Okay, let's take a look here. So why we are assuming it's a Young's modulus because we're talking about a metal wire, right? So this is stress over strain. If they did not give you the strain, which means you don't have to calculate for it. So what you are left with is only the Young's modulus, which is 3.75 times 10 to the 8 kilogram over meter second squared, which is also the same as Newton meter squared. So sini this is equivalent to F over A punya unit. Right, since they did not give you strain, you can solve this using F over A sahaja. So how do you do this? You just plug in equals to 5,000. Let me move myself. 5,000 over pi r squared is equal to this guy. You solve for r, that is your answer. So kenapa tak payah kira strain kat sini? Sebab the information is not given. So dia kasih elastic limit, dia tanya pasal radius. So radius is related to area. So itu je lah yang kita kena solve for. So answer, okay. So this is your stress. Okay, so dia solve for A kat sini. This is your area, which is F over stress. Pi r squared, the area of a circle, which Danish dah jawab betul tadi. And then dia solve for radius. Kat sini dia tak letak strain pun. Okay, dia tak letak strain pun. Which I find confusing sebenarnya. But kita kat sini kita letak Y equals to stress over strain. Since strain is not given, kita abaikan terus pakai F over A. So that's how I approach the problem. Okay. Yeah, the clue here is to look at the units sebenarnya. Okay, I hope that's clear for everyone. Okay, so moving on. If there are no questions, I'm going to move on to the next topic. Any questions?
Yes, doktor. Yang tadi tu, macam ni kita nak tahu dia betul-betul yang modulus ataupun sebenarnya dia adalah stress tensile?
Stress, you mean shear? Stress tensile.
Yang sebelum ni.
Okay, that's a good question. Because they have the same units, right? Betul. So stress unit dia Newton over meter square. And then your Young's modulus is also Newton meter square. Here they said elastic limit. So elastic limit is actually modulus. So itu je cara saya tengok.
Oh, I see. Thank you.
Itu je yang clue yang I got from this question. Okay, nanti dalam web assign, you are assigned with several questions on Young's, shear and bulk. You boleh tengok. If you don't understand, you can ask me. Ada soalan web assign. Ada 4 for this subtopic. Okay, moving on. Notes on elastic moduli or elastic limit. Solids have Young's, bulk and shear. Like we have seen before, kita ada metal wire which is solid. We have a book. Kalau shear stress, shear modulus, that's a solid. And then volume, a cube or a ball, that is also a solid. Liquids have only bulk moduli. Maksudnya, volume je lah. They can only change in volume. They will not undergo shear or tensile stress. Let's take a look at the table that we looked at tadi. So here kita ada solid, ada Young's modulus, ada value for shear modulus. We also have the value for bulk modulus. Solid like iron, steel, brass, aluminum, concrete, blah blah blah. Kat sini concrete tak ada shear. What happens if we try to put parallel force on a concrete? What happens to the concrete?
Ah,
Pecah.
Kenapa tu? Haikal? Okay, what happened? Oh, it's okay, je biar je. Nah. Okay, bye. Okay, why does concrete not have shear modulus? Can you apply shear stress on your walls?
No.
No, what happens if you do? What happens if your walls can have shear stress or shear modulus?
The house will collapse.
Yeah, the house will collapse. So that is why some material only have Young's modulus, they don't have shear. What's going on? Hilang. Okay, so certain, not all solids have shear and bulk. And then for this case, for liquids, we only have bulk. Gases only have bulk. Okay, so that is something to remember. Liquids and gas only have bulk. Solid can have Young, shear and bulk. Most of the time, they don't have shear and bulk. Okay, shear and bulk ni macam rare juga lah case dia. Okay, moving on. Okay, liquid would flow inside. Liquids only have bulk moduli. They will not undergo shear or tensile stress. The liquid would flow inside. Okay, what does this sentence mean? We will learn more on this. Okay, so we are moving on to hydrostatics, which will answer about the liquid flow thing. Hydrostatics. So after completing this chapter, you should be able to define and solve problems related to hydrostatic pressure, state Pascal's principle, and solve related problems, and also Archimedes. So there are two principles that we will learn here, Pascal and Archimedes. Okay, hydrostatic. What is hydro? Hydro means water. Static means in equilibrium. Okay, so that is what hydrostatic means. Sorry, hydro specifically for water ke campur gas sekali? I'm not sure. I will get back to you on that. Okay, so pressure. Pressure ni something that we hear every day. What is pressure? Pressure is actually force over area. It's almost the same as stress. No, it's not almost the same. It's actually the same. So pressure is a type of stress, right? When you have a ball, you apply force over an area, you are actually applying pressure on the ball. Apply some pressure, watch it shrink or doesn't shrink at all. So pressure is defined as force per unit area. The force is exerted perpendicular to the surface. This was the, equation for tensile stress, right? Tensile stress, which was F perpendicular over A. So force is exerted perpendicular to the surface. Pressure is a type of stress. Pressure is a scalar quantity, does not have direction. The unit of pressure in SI system is Pascal. Okay, the equation is Newton per meter squared, which is also equal to Pascal. Banyak kan? Just now we talked about Newton over meter squared is also equal to kilogram over meter second squared. It is also equal to Pascal. So there are three units that you can use interchangeably. But the official unit for pressure is in Pascal. So you will use Pascal as your SI unit for pressure. Okay, so that is 1 Pascal is 1 Newton per meter squared, just force over area. Okay, what do I want to say here? Okay, tak ada. Oh, about the scalar quantity. Okay. Okay, I'm not going to comment on that lah. Tapi if you are underwater, you know that water exerts pressure, right? The further you go down into the sea or the further down you are in the ocean, the more pressure is exerted on you, right? When we are over here swimming, oh my God, that's not me, that's someone else. Someone swimming in the ocean. This is the legs. Okay, so she's swimming, so not much pressure. He does not feel much pressure. There is some weight of water on the body, but it's not much. However, when he goes down further, goes down, 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 the pressure increases, right? That is why we can't go too far below sebab badan kita tak tahan. Okay, because there is so much force exerted on our body. At one point, our body cannot take it anymore, right? So what happens? Basically, you die lah. Okay, I don't want to say die, but that is what is going to happen if you go too far down. Okay, so sebab tu kita boleh menyelam ada level yang tertentu sahaja. Further down, selalunya kita hantar robots, right? Because robots can withstand the pressure. They are made from material yang tahan lah. Okay, so that is something to think about as we learn this chapter. What does it have to do with this chapter? Okay, pressure in fluids. Okay, if you have questions, please just interrupt me. A fluid exerts pressure in all directions. That is why it is a scalar quantity. Maksudnya, macam nak cakap. Okay, contohnya saya nak tahu pressure kat sini. The pressure at this level is the same. Contohnya, if the pressure over here at this dot is P1, the pressure at this dot is also P1 sebab level dia sama. Okay, so pressure only depends on the depth. If this guy is 10, this guy is also 10. This guy should be greater than 10. Let's say it's 20. So it only depends on one quantity, which is depth. When you depend only on one quantity, it becomes a scalar lah. If it depends on multiple directions, contohnya we had X, Y, Z, right? Here it only depends on one quantity which is going down further, increases in pressure. That is why it's a scalar. Apa lagi contoh scalar yang macam ni ya? Displacement is a factor. Distance. Tak boleh juga, distance ada arah. Apa yang depend on one quantity? Saya lupa lah, forgot. There is something that is similar to this. I can't remember. But it is a scalar quantity. Because of that, it only depends on the depth. And we will learn more on this. Okay. Sometimes you remember, sometimes you just lose it. Okay, never mind. Variation of pressure in fluids with depth. Korang, did I record this? Oh, I did. Nasib baik. Okay. Variation of pressure in fluids with depth. Okay, keyword here is depth. If a fluid is at rest in a container, all portions of the fluid must be in static equilibrium. Kita dengar term ni in previous semester. Static equilibrium means F net equals to 0 or torque equals to 0, net torque. Okay, tapi kat sini kita cakap pasal force je. Takut cakap pasal torque. So static equilibrium means net force is 0. Ke mana? Macam mana? Is it to the right? Is it to the left? Is it up or down? Tak kisah. All directions must be 0. Okay, let's see how that is. So keyword here is static equilibrium. F net is 0. Okay, let's see this object over here. Let me besarkan. Okay, we have a cube. It's not exactly cube. We have a box. Does that help? Okay, we have something lah. This object inside the water. So I tell you that this box in the water is in static equilibrium. What does that mean? It means that the force applied from this side to this side, F1 plus F2 must be equal to 0. Force applied on this side and this side, let's say this is F3, this is F4. So F3 plus F4 must also be equal to 0. Jump. I don't like this. Why is it equal to 0? Because I told you the net force must be 0. And kita hanya boleh add things that are in the same axis. I told you benda ni dependent on steps kan. But now we are talking about force. Force is a vector. So how do we add vectors or how do we minus vectors? Kita kena minus benda yang satu axis. Apa maksudnya kat situ? It means that I can only minus or add things that are in the same axis. This is in the x-axis. This is in the y-axis. So I can only add or minus F1 with F2. I can only add F3 with F4. Sebab it has to be in the same axis. Because force is a vector. Okay. Kita tak cakap pasal pressure kan. Kat sini kita cakap pasal force. Force is a vector. Okay, so if this object in the water is in static equilibrium, the net force must be equal to 0, which means that the force acting on the sides, either up or down or right or left, right, left, yes, must be equal to 0. So this is the equation. Oops, kenapa saya padam? This is the equation. F1 minus F2 should be 0, which means that F1 is equal to F2. And then because it is acting on the same size of area, right? We can say that over A, P1 is equal to P2 because pressure is force over A. Okay. So saya tambah kat A je kat sini to make it pressure. And yang senang kat sini, A dia sama. So we can just say over A je, tak payah A1, tak payah A2. Okay. Now let's talk about the vertical component. Okay, so I'm talking about F3 and F4 now. So F3 should be equal to F4 because the F net is equal to 0. Mana gambar dia? Oh, kat sini. Tak ada. Let me write it here. So F3 plus F4 is equal to 0. Kat sini negatif kan? Sebab dia cakap F1 to the right is positive, F2 to the left is negative. I can do that as well. F3 plus F4, because F4 is moving up, it is a positive. Because F3 is going down, it is a negative. So minus F3 over F4. Bila saya masukkan value, 0. So F4 is equal to F3. Okay, again, the area on the top is equal to the area on the bottom. So I can say that P4 is equal to P3. Same thing. Is everyone follow me so far? Am I moving too fast?
Yes, doctor.
Yes,
Yeah.
doctor.
Any questions so far? Okay, everyone's okay. All right, good. Okay, so I talked about force, by the way. But here you can see that there's another term in this equation. P2A minus P1A or force 2. Tak apa, nanti saya tulis balik. P2A minus P1A minus mg is equal to 0. Okay, why is that? Okay, I talked about F3 dengan F4 now, just now. But in this case, we have P1A, which is F. Let's say kita label ni. Okay, part ni dia confuse sikit Bear with me. Bear with me. Let's label this as P3. Aini Sofia, can you mute yourself, please? Okay, so P3. Okay ke? Panggil apa Sarah Aini Sofia? Saya lupa dah. Sarah Aini Sofia. Saya tak tahu nak panggil awak apa. Okay, P.
Sofia.
Panggil Sofia. Okay. Thank you, Sofia. So P3, P4, could I explain this? Sekejap, I don't want to label it P3. Okay, hold up. Let's go back to the F3 and F4 dulu. I need to explain this clearly so that you guys don't get confused. Okay, so saya cakap pasal F3 and F4. Atas dengan bawah kena sama sebab static equilibrium. Now, kat sini we have P1A and P2A. We also have the weight of the object, which is mg. Okay, so here I can see that F3 is equal to P1A. Okay, the force that is going down is P1A plus mg, the weight of the object. Okay, that is the net force going down. F3 is the net force going down. What is going down here? The weight of the object and also the weight of the water acting on the box. Okay, let me repeat myself. What is the net force acting downwards? It is the weight of the object, right? This is the guy. And also the weight of the water on top of the box because the water pushes the box, right? So ada weight kat situ, the weight or the force of the water acting on the box. So that is your force number 1. This is your force number 2. Force 1 plus force 2 gives you F3. Okay, hope everyone's clear on that. Okay. So we have, this is P1A and this is mg. What is the force acting upwards? So that is my F4. Okay, yang saya cakap tadi kat sini, F4. The net force acting on the box going upwards is only P2A. mg tak ada, mg only acts downward, gravity is downward, right? Tak ada gravity going upward, mampus kita. Oops, sorry for my language. So F4 is equal to P2A, which is force lah. For a P2 is pressure times A will give you force. The force acting on the bottom of the box. Okay. Now, F3 plus F4 should equal to 0. Right? F3 plus F4 should equal to 0. So here, let's say going downwards is negative. So F3 is minus P1A minus mg because F is a vector, right? So F3 plus F4 is actually P2A minus P1A minus mg. That is your vertical force equals to 0. Sama tak? Sama. Okay. So kat sini, P1A is not necessarily the net force. You have to consider semua benda yang going down, semua forces that is going down. What is going down here? The force acting on the box from the water, the force which is the weight of the box. Okay, so benda ni selalu orang lupa. mg ni selalu sangat students lupa. So this is why I wanted to explain this lama-lama. Okay, I hope this is clear. Okay, baru sampai sini. Okay, so let's move on. Okay, but mass is equal to density times volume. Where on earth did this come from? This is a simple equation. Mass over volume is equal to density. Mass is, therefore, mass is density times volume. Okay, let's talk about the units here. This is in kilogram. This is in meter cube. Volume is in meter cube. Density should be in kilogram over meter cube. When density is multiplied by volume, I am left with kilogram. So yes, mass is kilogram lah. Okay, just nak bagi tahu je units. Saya rasa ramai yang lupa pasal units. So mass is equal to density times volume. And volume is equal to area times height. Okay, again, if I have a cylinder, what is the volume of the cylinder? It is H times A. What if I have a box? Sama, A times H. So volume is A times H. So this is where the equation comes from, okay? But mass is equal to rho or density times volume, which is also equal to rho density times A and H. Therefore, P2 minus P1 is rho GH. Now, where did the A disappear? We had A in this equation. Now we have this guy. Where did our A disappear? Anyone? Where's my phone? Is everyone okay? Are you guys still following me? Senyap je.
Yes, doctor.
Okay. So where did the A disappear? Okay, let's talk about that. So we started with P2A minus P1A minus mg. And then I said, oh, mass is actually rho times AH. Right? Okay, so I need space. Let me find some space. Okay. Okay, so P, oh, this is too tebal. Okay, let me write down the equation. P2A minus P1A equals to mg. Okay, so now we want to substitute m into our equation, which is rho AH. Okay, let me do that. Rho, which is density AH. Sorry, AGH. Rho AH times G. Okay, sebab mg equals to mg tadi. So now we can cancel out A. Boring je sebenarnya. Cancel out je pun. Okay, so sekarang we have P2 minus P1 equals to rho HG. This is our final equation. Okay, so the difference in pressure. So P2 minus P1. P1 was up here, P2 is down here. The difference in pressure, okay, the difference in pressure, P2 minus P1 is dependent on H only. What is H? H is depth or the height that the box is in the water. Why is it only dependent on H? Why is it not dependent on rho or G? Because G does not change, gravity does not change. If gravity changes, you would be sometimes floating, you would be sometimes on ground, flying, you know. Gravity is constant, okay? In case you didn't know. So gravity is constant. Rho does not change, the density does not change. What density are we talking about here? The density of the water. Okay, so this is the density of water. So P2 minus P1, the difference in pressure, I can calculate the difference in pressure by just knowing the height, by just knowing the depth. Okay, so that is something that you need to take away from this slide. So difference in pressure is equal to, padam, bagi cantik sikit, is equal to the depth. Okay. Now, ni ada nota tambahan, H is equal to Y1 minus Y2. H is positive in this case because Y1 is greater than Y2. Why is it? Why is Y1 greater than Y2? This is Y1, this is Y2. By right, selalunya kita cakap this is 10. But kita going down, right? This is 10 and this is 5. But, tengok sini, it starts with a 0. Going down, which means that it is a negative 5 and negative 10. Contohlah. So here, negative 5 is greater than negative 10. So, negative 5 minus 10 is equal to 5, a positive value. So H is a positive value when we are talking about this equation. Can you not use a negative value for this equation? Yes. Let's say you just want to say, okay, let's stick with negative value dulu. Nanti kita akan cakap pasal positive value pula. Okay, so equation penting kat sini. P2 minus P1 is rho GH, the difference in pressure. of the top part with the bottom part is the difference in height. Okay, what difference in height? So this height minus this height, or vice versa. Asalkan value the positive. Let's do an example because this is quite confusing. Okay. Berapa? Oh, 12.5 dah. Habiskan. Okay. So never mind. Let's continue next class. Let's put our recap here. Excuse me. What have we learned for this subtopic? Come on, help me, guys. What have we learned so far?
The effect of pressure in water.
Pressure.
Pressure. Okay, pressure is equal to
F per A.
Force over area.
F over A.
F over area.
What is the unit?
1 Pascal.
Pascal or
Newton
meters.
over meter square.
Okay. Lagi. What is the equation for density?
Rho is equal to M over volume.
Mass over volume, and the units is kilogram over meter cube. Okay. Okay, what else? The difference in pressure, P1 minus P2, or was it P2 minus P1? Kejap. Atas P1, bawah P2. So P2 minus P1.
Equals to 0.
Equals to 0? Not correct.
Minus mg. Minus mg.
Minus mg. P2 minus P1 equals to, minus mg is equal to 0. Okay. So it is equal to mg, or rho g
GH.
Okay, what about the static equilibrium? What did we talk about?
The F net equal to 0.
The F net is equal to 0. F net must be equal to 0. Tak kisahlah, vertical or horizontal. So this guy has to be 0. This guy has to be 0. Okay. Apa yang penting bila kita cakap pasal vertical forces that equals to 0 ni? Apa yang extra daripada horizontal? Kita ada
mg.
Gravity.
Gravity mg.
This is why we have this equation. Okay, so I think that's it. Next class, which is tomorrow, starts at 10 to 11. Kita akan cuba habiskan. Alright? So I'll see you guys tomorrow. Bye-bye. Take care. Don't forget to eat lunch. Jaga SOP.
Thank you, Doctor.
Thank you, doctor.
Thank you,
doctor.
Thank you, doctor.
Bye-bye.
Doctor.
Kalau ada soalan boleh tanya personally or in group.
Doktor.
Ya,
Saya nak tanya satu soalan je, satu je.
boleh?
Kan tadi yang kita cakap pasal static equilibrium semua tu, adakah sebenarnya objek tu terapung dalam air tu ataupun dia sebenarnya dekat base ke atau dia memang terapung tengah macam tu?
Okay. If my net force is 0 in the vertical direction, maksudnya acceleration is
0.
Okay, so kita tahu the box tu dia tak accelerating downwards, dia tak accelerating upwards. Does A equal to 0 mean velocity is equal to 0 as well?
No.
Not necessarily, right?
Yes.
Okay, so boleh ada velocity asalkan tak accelerate. So that is what static equilibrium means.
I see. Alright. Terima kasih.
Alright. Any other questions? Tapi in this case, tak nak bagi confuse, let's just assume that diterapung macam tu lah. Okay.
Okay.
But in reality, in real world scenarios, velocity, it is possible to have velocity. Okay. Any Any other questions? Tak ada. Okay, bye korang. Bye. I will share the recording on YouTube as usual and lecture notes as well. Bye-bye. Ada soalan kita? Tak ada. Sofia ada soalan? Tak ada. Tak ada
Tak ada.
Okay, bye-bye. Stop sharing. Ada chat. Thank you, doctor. Okay, we welcome Divya and class.